Hi students, here's your review for Spiral 5. Starting off, we're looking at rational expressions and equations. We got to do some factoring on these guys. And my first step is always going to be to rewrite this exactly as it is, but with everything factored out. So on top we got a plus 10. The bottom is going to factor into a plus 10 and a plus 5. Again, you can use some kind of digital factoring help if you'd like. 3a plus 15 is going to factor into 3 times a plus 5. And then at the bottom we got a plus 7. The next step, you need to identify excluded values, things that would make the bottom equal 0. So a cannot equal negative 10, a cannot equal negative 5, and a cannot equal negative 7. Those are from the 3 pieces in the denominator. Then we got to do some canceling. A plus 10, a plus 10, a plus 5, a plus 5, and we're left with 3 over a plus 7 with these excluded values as our final answer. For the second one, we've got p minus 3, that stays the same. P squared minus 2p minus 63 is going to factor into p minus 9 and p plus 7. Divide, so that's going to stay the same for the moment. Then we're going to factor, it's the same exact thing on the bottom. So it's p minus 9 and p plus 7. We're going to do our excluded values. Again, going along the bottom, p cannot equal 9. P cannot equal negative 7. And we've got the same 2 in the next fraction, so we are in good shape. We don't use excluded values in the top because that would not cause us to divide by 0. We only care about denominators. All right, flipping my second piece over, we end up looking at this as p minus 3 over p minus 9, p plus 7. Divide is the same thing as multiply by the reciprocal, so we're going to have p minus 9, p plus 7, and 1 on the bottom. P minus 9s cancel out, and p plus 7s cancel out, leaving us with just p minus 3 over 1, which is the same thing as just p minus 3. Number 3, we've got some stuff to factor on the top and the bottom. On the top, I can take a 3 and a k squared out. So we end up with 3k squared and 5k minus 9. On the bottom, 2k squared is already factored for us. My division, and actually this one I'm going to do this in one step. I'm going to flip this first since we have nothing on the bottom that we care about right now. And then I can do the same thing because it's the same exact thing we had before. So that's going to be 3k squared and 5k minus 9. All right, excluded values. K cannot equal 0. That's my first one. And then 5k minus 9 cannot equal 0, which means that 9/5 cannot equal k. So that's for my second part. So that handles all 3 denominator pieces because k cannot equal 0 for that as well. Okay, let's cancel some stuff out. I've got 3k squared and 3k squared, 5k minus 9, 5k minus 9, and I can do 10 over 2 and get 5 on top. That leaves me with 5 over k squared as my final answer, with my 2 excluded values of k cannot equal 0 and k cannot equal 9/5. For the last one, we've got multiplication. X plus 8 is already factored for us. X minus 8 on the next one is already factored for us, as is x plus 8 on the bottom there. And then for 5x cubed plus 20x squared, from that I can take a 5 and an x squared out. That leaves me with just an x, and from that we get a plus 4. All right, excluded value time. X cannot equal 0, x cannot equal negative 4, and x cannot equal negative 8. Canceling stuff, x plus 8, x plus 8. Nothing else cancels, so I'm left with x minus 8 on top, and 5x squared multiplied by x plus 4 on the bottom. For solving these things, we tend to begin the same exact way, where we factor everything, we write down excluded values, and then we try to find some common denominators. So that's the new piece here. For 3k plus 6, I can factor a 3 out of that. I don't necessarily need to in terms of solving things, so I'm going to leave the numerator alone for now. The denominator of this is going to factor into k minus 3 and k plus 1. The second piece of this has 3 on top. We have the same denominator, so k minus 3 and k plus 1. And the last part we've already factored for us, so we just write that as k minus 3. All right, excluded values next. K cannot equal 3, and k cannot equal -1. Those are for my denominator pieces. Now we have to find some common denominators. Both of the first two have k minus 3 and k plus 1. The last part only has a k minus 3, so it needs a k plus 1. And I've got to have k plus 1 on top and bottom there. Okay, at this point we have all denominators the same. That means that we can eliminate those and write the equation as 3k plus 6 plus 3 is equal to 4 times the quantity, I wrote that as k, that's fun, 4 times the quantity k plus 1. That's going to be 4k plus 4 is equal to 3k, 6 plus 3 is 9. Bring things to the opposite sides, we end up with 1k, and then 5 on this side. That's my answer. I'm going to check to make sure it does not match either of those, and we are in good shape. We have no extraneous solutions. For number 6, we can factor x squared plus x into x times x plus 1. We got a 1 over x. I'm going to leave some room because I know I'm going to have to add some stuff in there. And then we've got 1 over x times x plus 1. Excluded values cannot equal 0 and cannot equal -1. Common denominators. All three already have an x. X plus 1 and x plus 1. The middle guy needs that, x plus 1. So we end up with 4 is equal to x plus 1 and then plus another 1, which means that 2 is equal to x. That's not one of our excluded values. We're good. Next up, we've got graphing exponential log equations, and we're really going to focus on writing equations from graphs instead. First thing is that my horizontal asymptote is going to be 1. That's always going to be our k value, so we start out with that. Then I use my y-intercept. So we got 3 is equal to a times b to the 0 plus 1. 2 is equal to a based on this. I'm going to use my other point to solve for b. So we've got 7 is equal to 2 b to the -1 plus 1. All right. So we have to deal with a negative exponent. That's a little bit uncomfortable for us. That's why I chose these problems for this week. We're going to minus 1 to the other side, divide by 2, and we get 3 is equal to b to the -1. I'd like to remind you that b to the -1 is the same thing as 1 over b. So if 3 is equal to 1 over b, that means that 1 over 3 is equal to the reciprocal, so b over 1. My final equation for this is y is equal to 2 is my a, 1/3 is my b to the x, and then plus 1. Looking at another one of these, we're going to have the same type of thing going on, where my k is going to be -3, because my horizontal asymptote is at -3. Let's find a next. So I'm going to use, that's fun, 0 is equal to a times b to the 0 minus 3. I add 3 to the other side. We get 3 is equal to a, because b to the 0 is 1. And I'm going to use the other point. We have a negative again to find my b value. So plugging that in, we get 3 for the y is equal to 3 for the a times b to the -1, and then minus 3. Lots of 3's going on here. If I add 3 to the other side, we get 6 is equal to 3b to the -1, which means that 2 is equal to b to the -1. And again, this is a reciprocal, so that means that if b to the -1 is 2, b is going to be the reciprocal of 2, so is 1/2. My final equation here is going to be 3 times 1/2, to the x, and then minus 3 at the end. Next up, we got to convert between exponentials and logs. I'd like to remind you that we have this log base of some argument is equal to an exponent because logs are exponents, and that matches up with a base to an exponent is equal to that answer. So when we're looking through this, we've got our base, our argument, and our exponent. That means that x to the 8th is equal to y. We've got our base, our argument, and our exponent. That means that a to the b is equal to 171. Going backwards, we've got our base, our exponent, and our answer. So this is log base v of u is equal to -1. And same thing for number 12. We've got our base, our exponent, and our answer. That means that log base 8 of b is equal to that exponent a. We're going to do the same thing to evaluate log expressions. We're going to convert, but we have to set them equal to an exponent first. So we get 4 to some power is equal to 64. And if you look this up on a table or plug things in, we find that that exponent has to be 3. 4 to the third power is 64. For number 14, we're doing the same thing, setting that equal to an exponent. And when I do that, we get 3 to that exponent is equal to 81. You can use a table of powers or guess and check, either of those is fine, to find out that has to be the fourth power. For number 15, this can be a little bit trickier because we're going to have this equal to some exponent, and 3 to some exponent is equal to 1 over 27. Well, I know that 3 to the third is equal to 27, and I know that negative powers give me reciprocals, so 3 to the negative third would be 1 over 27. A shortcut is finding whatever that power is for the bottom number and then make it negative. So in this case, that would be -3. So for number 16, let's talk about what that might look like using that method. So we're looking for 7 to some exponent is equal to 1 over 343. If I can find 7 to something is equal to 343, the negative of that is going to be my answer. And if you look at a table, you're going to find 7 to the third is 343. If I want a if I want a flipped version, I need the negative version, so -3 would be my answer. In terms of solving these things, our goal is going to be to first get the exponential part by itself. So I'm going to add 3 to both sides, and we've got 14 to the 7v is equal to 31. These are not clean things, so I've got to convert this to log of base 14. So log base 14 of 3 is equal to 7v. And then to get the v by itself, I've got to divide by 7. My final answer is log base 14 of 3 divided by 7 is equal to v. Same thing for the second one. We're trying to get the exponential part by itself. We're going to divide by -2 to start things off. We get 3 to the x minus 5 is equal to +40. Again, these are not the same base. I have to convert to logs. Log base 3 of 40 is equal to x minus 5. To get x by itself, I'm going to add 5 to the other side. My final answer is 5 plus log base 3 of 40 is equal to x. For number 9, we're doing the same process. We have to get the exponential by itself. We're going to divide by -10. So we've got 13 to the a plus 2 is equal to -27 over -10. I'm just going to write that as +27 over 10. You could write that as 2.7 if you wanted. Either one is okay. I'm going to convert to log. So log base 13, 27 over 10. And that's equal to a plus 2. I'm going to get a by itself by minusing 2 to the other side, and we end up with log base 13, 27 over 10 is equal to a. All right, for number 20, we're doing the same thing. We've got to get the exponential part by itself. I'm going to add 5 to both sides. 18 to the n minus 2 is equal to 58. convert to log. Log base 18 of 58 is equal to n minus 2. I'm going to add 2 to the other side. 2 plus log base 18 of 58 is equal to n. And then the last thing, we're going to do some log properties. We've got to either expand or condense these things as appropriate. And first I want to talk about expanding things. I've got a couple rules of thumb here. Things that are multiplied are going to end up as adding things. Things that are divided are going to end up as subtracting things. So for the first one, it might make sense for us to kind of break this up into pieces first. So I've got log base 2, and I'm going to have a log base 2 for each part of this. Because we're multiplying all three of these are going to be added. So you've got a plus log base 2 of b plus log base 2 of c to the third power. The other piece that I've got to have is if I've got an exponent on the inside to expand, I'm going to bring that down front. So my final answer would be log base 2 of a plus log base 2 of b plus, again, we're going to bring that power down, 3 times log base 2 of c. Sometimes I do that as a shortcut to do this in one step. I'm going to show you what that looks like on 22. So all these are going to be log base 7. I've got a times and a times. Everything's going to be added together. So it's going to be log base 7 of 8 plus log base 7 of 5 plus, and I know I'm going to have to bring that power down. So I'm going to write that as 3 times log base 7 of 11. Similarly, for number 23, I'm going to write this as log base 3 of x. I'm multiplying, so I'm going to add these together, plus log base 3 of y, and I'm going to multiply, so I'm going to add these together, plus bring that power down front, 2 log base 3 of z. Same thing for 24. This time I've got 2 powers to work with, so I'm going to bring both of those down. That's going to be 5 times log base 3, wrote that too big, of 11. And then we're going to bring that 6 down, 6 times log base 3 of 6. When we're condensing these, we're going the opposite direction. And I tend to try to think about these in a really similar fashion. I know I'm going to build one fraction. Anything that's adding together is going to go on top multiplied. Anything that's subtracting is going to go on the bottom. The other thing I have to be aware of, and I'm going to do the first two in 2 steps, and then I'll do the bottom 2 kind of all together, is that numbers out front are going to become exponents. So in one step, I'm going to rewrite this as log base 7 of u to the 4 plus log base 7 of v to the 24. And now I'm going to combine these things into one log. So log base 7, adding means multiply. So u to the 4, v to the 24. For number 2, here we have a couple things that are being divided by 3. What that really means is that this would be 1/3 log base 2 of u. I could either write that as a 1/3 exponent or as a cube root. Those mean the same thing. But the same type of thing is going to happen here, where I'm going to have my powers first, log base 2 of w, plus log base 2 of u to the 1/3, plus log base 2 of v to the 1/3. Then I'm going to combine these. All 3 are being added, so I'm going to make one log and multiply those pieces together. So u to the 1/3 and v to the 1/3. And again, if you'd prefer, you could write this as the cube root of w and the cube root of v. You could even put those inside the same cube root if you wanted to. You don't have to. Either of these 2 is okay. For number 27, I'm going to see if I can manage this without doing this in 2 separate steps. And to do that, I'm going to think about this as a positive thing, because we're positive out front. This is a negative thing. So when I build my fraction, the positive part's going to go on top, the negative part's going to go on the bottom. So we're going to have 1 log, which is log base 2. And on top of that, I'm going to have a. And I'm going to have a with a power of 12. On the bottom, I'm going to have b. And because that's a 6, I'm going to bring that up, and b with a power of 6. I hate problems that have b's and 6's in the same problem. They always look the same to me. And at this point, the problem is done. So you can do that in one step if you want. You could also do the powers first and then set them up as a fraction. Either way is okay. For number 28, we're doing the same thing. Here we've got 1/2 powers. All 3 of these are positive, so we're going to be multiplied together. This is going to be log base 9. We're going to have w, and u over 2 is the same as u to the 1/2. V over 2 is going to make that v to the 1/2 on the inside. Similarly to the one that we did right above this, you could rewrite that as log base 9 of the of w times the square root, that's the 1/2 power, of uv. Either of these two is completely correct and will get you full credit.